Hello, my name is Martin Wakeman, and I have quite a difficult task trying to describe what a plant information model is, as each of you will already have a different interpretation already formed in your mind. Is a PIM a 3D design model, or is it something more? And our team had the same difficulty. So, I am going to try and explain what a PIM is, how it can be built, the difficulties and the benefits of investing in a PIM. I'm going to then briefly introduce the concept of a knowledge PIM, a K-PIM. I have about 10 minutes, so I'm not going to hang around. If you want to follow up some more, then you should initially read the IAEA document that we produced, and then contact the IAEA team. The document states that a PIM is a set of interlinked information about plant structures, systems, and components, incorporating plant data, relationships, and rules used to integrate, represent, and describe nuclear facility processes and data for each phase of the facility lifecycle. A comprehensive plant information model would give us the ability to quickly access all the data associated with each system, structure, or component. Speed and accuracy of information at the push of a button is the ideal scenario. The document goes into more detail about how this can improve many things, including safety and efficiency of the plant. Data can come in many forms: a 3D model, drawings, documents, calculations, data sheets, maintenance data, test data. It is not only the design data, but from all stages of the life cycle: requirements data, design data, the safety case, construction, manufacture, installation, testing, operations, maintenance, engineering, etc., etc., etc. So a PIM will incorporate information from all stages of the life cycle. And so, how beneficial developing a PIM will be will depend on where you are in the life cycle and what your business drivers are. Obviously, the earlier you are in the life cycle, the better. If you begin at the design phase or before, you have the ability to collect information as it is created through planning, requirements gathering, design, construction, manufacturing, installation, commissioning, and into operations. And there are some great tools around to do that, as we will see later from the contributions of my co-presenters. Whilst the ideal scenario would be to start to build a plant information model starting from the design phase or even before, if your starting point is in the operational or later stage of the plant lifecycle, the plant information is already embedded in a number of IT systems and documents that may or may not be integrated or easy to get at. This picture represents the typical IT functionality needed in an operational power station. Whilst a lot of this functionality may be invested in a single Enterprise Asset Management (EAM) system, no one system can incorporate all this functionality, nor should it. Therefore, the information to build a plant information model lives across a number of systems. And not all that information is data. Much of it is embedded in documents that may or may not be easily searchable. Here, the first stage of the approach must be to identify the relevant importance of each data and look at methods to bring this information together in some way. I don't have a magic ready-made scenario for this. Each case would be different and must be driven by a review of business benefit. Even if you ideally start from the design phase, you are potentially looking at information from many different suppliers from many different systems, unless you make the decision to design with integration in mind. And when you look at the systems that may be required during the construction phase, as in this diagram, you can realize that there are still more systems and companies you have to integrate to build a PIM. Even at this stage, it will require a great deal of planning, financial commitment, and management commitment. This data may be from designers or from component suppliers who may be way down your supply chain, in a different country perhaps. And when you ask for designers or manufacturers or constructors to give you the data to build up your PIM, Then there will be difficulty with systems, standards, and cultural issues. The most frequent response is, "We've never done that before. Why do you want that now? That will cost you more. Our systems can't do that." Another issue will be in defining the standards for data that you are asking for. This next diagram is a very high-level representation of the responsibilities to build a PIM in a new build situation. Each of these boxes obviously can be expanded. In order to build a PIM, sometimes called a digital twin, in a nuclear new build process, the owner-operator must firstly specify to the EPC, the engineer, procure and construction company, or companies, exactly what it wants in terms of information requirements. This will be the information it needs to operate a safe, effective and efficient plant for more than 60 years, and to be able to decommission the plant beyond that. These information requirements must be included in the contract documents. If they are not in the contract documents, then they will not be delivered. It is the role of the EPC organisation then to collect, verify and manage this data and to manage change before eventually handing over the digital plant to the operators alongside the physical plant. I could spend the next half an hour just amplifying this diagram alone, but I simply don't have enough time. For instance, how do we specify the operational information needs? Remember that we don't just want to replicate what we have on plants built 25 years ago, but want to build a PIM for a plant for the next 60 years. My time is nearly up, so I want to touch upon how we fully extend a plant information model, our PIM, into a knowledge PIM or K-PIM. Again, I can only skim this topic, and if you want to know more about knowledge management, then the IAEA have some excellent people and reference sources. I'm going to start by introducing this diagram, which appears in much of the literature, and also appears in the IAEA PIM document. To me, this is the most annoying diagram in the world of knowledge management, as in my opinion, it should look something like this. The aim of knowledge management must be to convert what is information, what is knowledge, and what is wisdom into data. Knowledge held in somebody's head is useless to anybody else. All knowledge must be converted to data. That data can be a document, an email exchange, a database, a 3D model, or a YouTube video. Then the important thing is to develop methods of extracting that information or knowledge or wisdom, and hence we get into the methods of connecting our data elements using semantic tools and taxonomies. It's a complex issue and one that you may help find solutions for. Thanks for listening and good luck with your journey.